You know, when I watched them receive in the Bible and DC, they had like actual Hebrew scribe there with like the actual hide and stuff, and was scratching under it. It was kind of cool to look at.
Yeah.
But they were giving out free Chinese.
Free Chinese.
Yeah, I knew someone who's learning Chinese players.
But you know I'm fluent. Well, I'm fluent in Mandarin. I'm fluent in like 25 languages. I know Telugu, Hindi, Urdu. Urdu's the, what's this?
You can get on. Fun, huh?
Yeah, it's just a hobby. I got it.
A lot of those are programs.
None of those are programmed. Telugu's, I know I'm decent with the language called Tamil, which is from the Indian state just to the east of Telugu.
But they mainly like different Indian dialects.
Yeah, but it's substantially different. It's not like people from Texas versus people from New Hampshire. It's a whole different thingamajig. I did. Well, I didn't put it on Blackboard. I put it on Slack. Put in a link last class. I'll never put the links to code on Blackboard because that takes me time. It takes me no time to put it on Slack. All right, so let's get rolling. All right, so we were talking about inheritance last time, doing it the right way. And we decided that per our picture here, all players are inhabitants while all inhabitants are objects. So we had previously talked about there's this little hidden thing here called that says extends object sitting in here that we don't have to type, but this is how object-oriented languages work. Every object-oriented language works this way. There is a core object class that is the basis of all objects. And our goal as programmers is to limit the amount of code duplication that we have. So we say that all inhabitants have names. And then we say players have that same base of an inhabitant. Every player has a name and every monster has a name. So we'll go ahead and let player and monster inherit from inhabitant, and they'll go ahead and receive that name attribute. And then we will differentiate. Why? Then we'll differentiate players and monsters further to make them that much different than inhabitants. All right. But an inhabitant is an object. Typically object-oriented lingo, all these relationships are called is-a relationships. And I know that seems weird, but that is what they're called. It's an is-a relationship. A player is an inhabitant. An inhabitant is an object. All right, and we do have an operator, and we'll see this as an example, but we have the instance of operator for detecting if a instance is a member of a certain class. Oh, I think I'm just off the end here. So if we had an instance of player, it would be true that, let's say we have an instance P here. P is an instance of player. Is P also an instance of inhabitant? It's not. P is an inhabitant, but it's actually an instance of player. But we could create an array, for example. I could do something like this. Inhabitant array AR is equal to a new inhabitant array 10. And this array AR is capable of holding 10 inhabitants, which is a collection of players and monsters. Make sense? But as I'm going through that collection, as I pull each instance out, I might be interested in, am I dealing with a player or am I dealing with a monster? That's where that instance of thing kind of comes into play. We'll probably see that as through an example at some point, but that's kind of the punchline here. Now, generically speaking, we don't expect to ever have generic inhabitants walking around. That's not a thing in the real world. We don't, as you're walking the halls of Concordia, you never bump into a generic human, right? Just whatever the core attributes of every single human being, you don't run into something that's just that, right? Everybody is further defined into subcategories, okay? So we would say it never makes sense. That's one of those clones from the Alien movies, right? Yeah, if you ever run into one of those, then, make sure you read the sequels. They almost never, well, they almost always end well for the humans, but there's a really bad spot in the middle. All right. So to kind of show you how we can control this, how we can police this, let's go a little further with this. So we're saying an inhabitant has a string name, and we've advertised that we make our fields private and then loosen the reins as we need to. Here's the constructor for inhabitant. It takes a name in as a parameter, and it just sets this guy's name field equal to whatever name was passed in. Fine. Go into player. A player extends inhabitant. The constructor for player also takes in a name, but we are not saying this dot name is equal to name here. First of all, we wouldn't be able to say that because player is not inhabitant, and name inside of inhabitant is private. So it's only accessible inside of inhabitant. We might choose to change that in a few minutes, but there's two reasons here why we're not doing that. One, this is an illegal line of code because we don't have access to that field within player. But secondarily, I mentioned a few minutes ago that one of our goals is to not duplicate code. Doesn't that line right there match that line right there? It's the same code. If I already have a tool that knows how to set the name, I mean, obviously this guy isn't doing tons and tons of stuff. It's just setting a single variable. So if we did duplicate that, it wouldn't be the end of the world. But we already have a tool that knows how to initialize that name variable for us. So we're going to go ahead and call upon our parent's constructor. And that has to be the first line in there. If you're going to make a specific call to your parent's constructor, it has to be like that. All right. An interesting thing I want to show you here real quick. Inside of inhabitant, I think I mentioned last time that if you don't create your own constructor, a invisible no argument constructor is created for you. You'll never see it, but it's there. So let me just do that. We're going to leave player just like that. So a player is an inhabitant, and we have not actually further defined it. Okay. And you look at this and say, hey, this looks okay to me. No problem, no harm, no foul. Let's get back to main here. Here's me creating my player. Well, we're going to get there anyway, so I'll just run it. It's going to complain about our constructor for inhabitant, presumably. It didn't click. Need to hide this until I accidentally press escape again. Let me reintroduce my error real quick. Just going to dump that guy. We will save. We'll go to main. We will run. All right. So inside player, it says constructor inhabitant in class inhabitant cannot be applied to given type. Because inside of player, there is a invisible thing here. It's calling the parent's constructor because that's super. I think I said last time that there's sort of kind of this thing in here. Super is equal to new inhabitant, something like that. It actually isn't written just like that, but that's effectively what's happening. We're getting a value associated with that variable called super. That is how an object references the instance of its parent, which means that every instance of player also has an instance of parent on top of which it is created. So that instance needed to be born. All right. But when I leave it completely blank like this, it's complaining about player. It's saying, look, there isn't an instance of the constructor for inhabitant in class inhabitant cannot be applied to that. I'll go ahead and run this again. And we should get the identical error. All right. So there's your evidence that that hidden line was there. Okay. So this is one of the reasons why Java is so cool, but also why Java can be an infuriating initial language because you don't understand what's actually happening for you. So when you get a weird error like this, you're like, I didn't write anything in player. I didn't even reference. If I go back to player here, I never even talked about inhabitants in here other than saying an extended inhabitant. But inhabitant worked just fine. What's the big deal here? It's because there is a magic line here that's trying to call, since I didn't write it, it's trying to call the parents constructor with no parameters. Now, if I go into inhabitant, and just for a moment, I get rid of that. We will save again. Here, I'll hit run. Oh, where's that? Is that in Monster? Give me a moment. Right now he's cool with it. I actually took code away from inhabitant. And now he's like, oh, everything's fine. Why? Because inhabitant, if you don't write a constructor, it gives you a constructor that takes no parameters, that does nothing invisibly. So that exists, which then allows this invisible line to work. Does that make sense? If you don't write anything yourself, those are the things that are provided for you to make the hierarchy of object-orientedness work. Realistically, most of the time, when we create objects, we are going to write our own constructor to initialize stuff. You don't have to. If it didn't make sense for your object, maybe you're using an object kind of like a struct. If you were going to create an object in Java to behave like a struct, where you just had a bunch of maybe public fields that you just set, a player had, p.name is equal to this, p.jersey number is equal to this, something like that. You can do that if you wanted to. Remember structs from C++? Java doesn't actually have a struct type. So if you wanted to sort of kind of fake a struct, you maybe would say, oh, I don't need a constructor. Although I'd make the argument of, hey, it's actually a better struct if you do use the constructor. But so we can loosely make an argument of why you might not write your own constructor. Or we could say, well, what if an object didn't really need any initialization because it kind of gains its values maybe later on? We set some other things as part of the program later on, then maybe you can make the argument of why you wouldn't actually write your own constructor. Generally speaking, though, we would say this is what it means to initialize an inhabitant. Take in the name, set the name. All right. So since we have defined our own constructor, Java will not create a no argument constructor that does nothing. We've overridden that default behavior by writing our own, which then means the default behavior in here, there is no longer a constructor in inhabitant that takes no parameters. That line breaks. The invisible version of that line also breaks. And we'll see that again. I think we saw that a few minutes ago, right? Expecting coffee, Diet Coke. I like Diet Coke, but that's not what I was expecting when the Right, yeah, it was a thing. It's actually Diet Coke mixed with Diet Mountain Dew. 2-day-old Diet Mountain Dew. Waste not, want not. It's expertly aged. It's like a fine wine. All right. All right. So do we understand why these are errors? All right. And this comes down to this invisible stuff that Java puts in there for you, which is a great convenience for us as programmers in the know. But if we're not in the know, and this is your first language you're ever learning, you're sitting there banging your head like, why is this an error? It's complaining about code I didn't even write. Make sense? All right. So in any case, we already have a tool that can set the name for an inhabitant. It's in the constructor of inhabitant. So a player will go ahead and call his parent's constructor, passing in that name. The player constructor takes in the name rather than him setting it directly, which is illegal right now since name is private. We are just going to pass the buck and go ahead and tell our parent, look, you do your initial setup, and then I'll add a couple of things, maybe. Make sense? But this call to the parent's constructor must always be the very first line. Very important. We'll do the same thing in monster. So technically right now, players and monsters are fancy named inhabitants because they still are only a name. All right. I'll keep those in there for now. Here's our two monsters. We'll go ahead and print out. We'll say P instance of player just to show you that operator. So this is actually a Boolean operator, but it's a Boolean operator that operates on objects. The left side is an instance of an object. The right side is a class name. It's all lowercase. You're not going to let me get away with that, are you? Syntax is instance of class, followed by instance of, followed by class name. Can't paste that. And this guy returns true if instance of class is a instance of class name and false otherwise. So this allows us to ask questions about instances of objects relative to the parent. Go ahead.
So is this not stored within the generic object class? It's in a dot reference there.
Correct. Yeah, absolutely. So he's asking the question, since the syntax, well, let's look at the code here. This is not something that belongs to P. Instance of as an operator, just like double equal sign or less than, that's built into the Java language. It's not a method of object. It's not a method of inhabitant. It's not a method of player. It's something that exists for working on those types of things. And he questioned that because he said, you didn't use the dot notation there for kind of gluing those guys together. So this is a completely separate dealio. Good observation. Go ahead.
Yeah, it's just true right there. Like, I put in and it didn't say false.
I think it's the monster. These are the monsters.
Yeah, but isn't it the purpose?
Incompatible text monster cannot be converted to player. I wonder if I need to put it in a Boolean variable. It's a good observation because it is funky. I was trying to get it to evaluate that first and then try to print it. Let me throw this into a variable here. Print out B. Hold on, let me look at monster for a second. That guy is an inhabitant, yada, yada, yada. Here's an inhabitant. M, instance of player. M is a monster. We're asking, is this guy an instance of a player? Oh, let me, it's accurate, but let me explain why. I'm going to go ahead and say inhabitant array AR is equal to a new inhabitant. That's not even close. Inhabitant. Put two buckets in there. We'll say AR at bucket 0 is equal to P. AR at bucket 1 is equal to M. So now they are stored as generic inhabitants. We don't need to add, I mean, so really this question doesn't make any sense because M has an identity. It is a monster. We don't need to ask questions about, is a monster a player? That's like saying, is the number 5 equal to is the number 5 the number 7? They're the same thing. But the point will be this. So if I say AR at bucket 1, is that guy an instance of player? Is the generic inhabitant, I mean, we know we put M, which is our monster. We know we put it at bucket 1 of AR, but AR is an array built for holding inhabitants, of which players and monsters are those, right? So that means a bucket built for holding inhabitants, I can throw both players and monsters into that bucket. But when I take them out, they come out as a generic inhabitant. Even though under the hood, if we peek, you know, it is a player or it is a monster. So AR at bucket 1 here will be a generic inhabitant. And we can ask the question, is that generic inhabitant actually an instance of player? And now this guy will be false. So really my original example was a bad example because it wouldn't be a situation where you would use instance of. You would use instance of when you have kind of generic versions of things that you know actually might be other things. And it allows you to ask, is this guy actually one of those? Is he actually one of these? Make some sense? And you might, I mean, this is going to be something you might rarely use. You might say, look, if I'm going to, for instance, for a room, in a room, we can say we're going to have an array of inhabitants because a room might have a bunch of players in it, it might have some monsters in it. Or we could just say, you know what, I'm going to have an array of all the players that are going to be in this room. I'm going to have a separate array of all the monsters that are going to be in this room. Then you don't have to ask, is this generic thing one or the other? When you're dealing with the players array, it's filled with players. If you're dealing with the monsters array, it's filled with monsters. So we would have a choice to avoid using this. Go ahead.
If you were to play players, right, the same thing, it's still like you wouldn't change the AR and what you want.
What do you want me to write?
Like just replace it with player.
Up here?
No.
Oh, this guy. I understand what you're saying. You're asking, is this guy going to be an instance of inhabitant? I think we're going to get the same error we had before because we know it's going to be an inhabitant. Oh, because we put it inside of an array, we should get the same error though if I do this. Inhabitant I is equal to new inhabitant. I gotta give it a name. And then I say I is an instance of inhabitant. Now we should get our error.
When you put
What?
Why is that an error? When, oh. Why is that though?
like, so is it like, okay, where you could just had I, if you have like AR at, when you do AR at bucket 0.
Yeah, because that is a player. So AR at bucket 0, instance of inhabitant. It's not an instance of inhabitant. Okay, well, it is then indirectly. We go to our picture. A player is an inhabitant. Therefore, instance of returns that. So we can identify things that are inhabitants by asking instance of on either of these instance types. It wouldn't go the other way, though. We could not ask, is I an instance of monster? That's a false. It is interesting, though, that we didn't get the error. The thing that did give us the error was, I said, is P an instance of monster? That's what we had.
And
Oh, so this should be the same thing, though. Yeah. We're playing. So if we're dealing with the generic type to things that are children of it, then it's okay. But if we're comparing two child types to each other, it says that doesn't make any sense. Why you're asking that question? I'm not sure I would have implemented it that way. I mean, the reality is you're never going to run into these situations because you're only going to ask the question if you are pulling something generic out and saying, what are you? If you're a monster, do this. If you're a player, do this. That's the use of instance of. But it is interesting to me that it gets a error, player cannot be converted to a monster in this particular situation. I mean, I probably can say, treat this guy as an inhabitant and then try to do the instance of there. They'll let me get away with that, but I do find it, because I mean, I know it's a player. I know it's not a monster, but it's not going to let me check to see if a child class of an inhabitant is an instance of a different child class of an inhabitant. So I can go ahead and say, pretend that P is an inhabitant. That's the same thing as effectively saying AR at bucket 0, because that's me throwing P into a bucket for holding generic inhabitants. If I were writing instance of, I wouldn't have it ever throw an error. I was going to say, look, you gave me an instance of something on the left. You asked, is it an instance of this class on the right? The answer is yes or no. Okay, if you ask a stupid question, the answer will just be false. It's not one of those. I'm not sure I love the behavior of that, but it's probably nothing you'll run into in reality unless you're just trying to kind of show all the things like we're doing here. You shouldn't run into it because really the use of this, let's just use it in a practical use. We would say if, here, we would probably do something like this. For it I is equal to 0, I is less than AR dot length, I plus plus. If AR at bucket I is an instance of player, system.out.println, player found. Else if AR at bucket I is an instance of monster, monster found. Even though we know we could have just put it inside of it else, but we'll just let this fly like this. So now what it's going to do is it's just going through this array of generic inhabitants. And each time through, we're asking a question. The current bucket that we're looking at, what kind of thing is it? Is it a player or is it a monster? And we're doing different things depending on which of those it is. That's the use of instance of when we're operating on a generic, a collection of, in our case here, inhabitants. So this should give us player for the first bucket, monster for the second bucket. Because we know that's what we put in there, but when it comes out, oops, bad variable I, because I created a generic inhabitant. There we go. This is like the proper use of instance of. I got a generic collection. I want to find out what kind of animal I'm dealing with, because when I pull it out of there, it's coming out as a generic inhabitant, even though we know we only threw players and monsters in there. Make sense? All right. So in our dungeon crawler, we would run into this maybe if we decided for a room that we wanted to just have a collection of inhabitants that covers all players and monsters that might be in the room, as opposed to having a collection of players and a separate collection of monsters. That would be just a design decision we would make as programmers. If we had them separate, we wouldn't need instance of. If we had as a single collection of inhabitants, then we might need to use instance of when we need to treat players and monsters differently. Okay. So now let me ask you this question. Well, so any questions about this inheritance model that we're dealing with? Don't worry about the instance of too much. I don't want to beat a dead horse with that. Now let me ask this. That's why I asked it a few minutes ago. In real life, do we ever run into the generic human, or is it always a subtype of human, right? Okay. So realistically, saying inhabitant I is equal to a new inhabitant, and we are allowed to redefine I here, since the scope of I here lived and died with a for loop. Remember that? Okay. Would this ever make sense in our program? Well, it's an error right now, but I like LOL as a name. I'm almost positive somebody has named their kid LOL. Yeah. Oh yeah. Some of the things people name their kids. Does this ever actually make sense? Not is it legal, but would we ever want to create an instance of inhabitant? Just like in real life, we don't have generic humans walking around. So in our game here, we would only create instances of players and monsters, never of inhabitants. Inhabitant exists specifically to be the core of what players and monsters are. So we have a way of policing that, because right now it'll let us create an inhabitant. No problem. It's not illegal to do so, because we've written our code in such a way that inhabitants are plain old classes just like any other class, and we can create instances of them. In most object-oriented languages, well, I would say in all object-oriented languages, they have the equivalent of this. But we have something called the abstract keyword. Making a class abstract, and it actually also works on these things called interfaces, but just throw that in the trivia bank at some point. Making a class abstract means that you cannot, I think those actually run together in the real spelling, right? I think that's the real spelling of that, which looks weird, but I think it's right. Making a class abstract means that you cannot create an instance of that class. You can create instances of children of that class. So abstract is our way of self-policing our code to prevent us from creating instances of classes that were never meant to be instantiated. Instantiated. And this might be less for you since we're the ones designing it, but more for the people you might hand your library of things to and say, here's a bunch of classes you might want to use. By the way, you're not allowed to create instances of this one. He's there as a building block to support inheritance. Go ahead. Sort of is reasonable enough to say. I think they're solving different problems. So what we would do here is we go into inhabitant and we would say public abstract class. And by making that change right there, this line right here becomes illegal. Inhabitant is abstract. You can and cannot be instantiated. Make sense? So that makes sense for what we're trying to accomplish here. Inhabitant for us exists solely as part of our inheritance model for what we're building. We want players and monsters and they share some traits. So we put those traits inside of the abstract class inhabitant and then extended that for these two guys. But it never makes sense for us to create an instance of inhabitant. All right, makes sense what abstract does? You can get away with never using abstract in your entire programming career, but that then makes your classes maybe a little bit more loosey-goosey, where people could create instances of things that maybe you never intended for them to create instances of, but you know, kind of swim at your own risk type thing. And I guess so you could take that approach too. Possibly. Actually, I would say a lot of like when a game crashes, since a lot of our modern games are still written in C++, it was because you had either a memory leak or you had corrupted memory, where kind of like we were looking at the malloc versus just using the shortcut stuff for an array, where the memory that was created actually disappeared at the end of a function call, and they're trying to still access that memory later on in the program, thinking that it was there. Things like that. The second your program tries to go and grab the value at memory that you don't own, it's going to flip out. Modern day languages like Java and C#, they have something called exception handling, which I would say is not necessarily commonly used, mostly because programmers are lazy, including myself. Really, the times that you use it are when the language forces you to. There's something can throw an exception, and when something throws an exception, that means you have to deal with it. Okay, if something throws a runtime exception, you don't have to deal with it. You maybe should deal with it. It's a strong suggestion. And we'll see those by example at some point. We'll probably look at them with C#. All right. So in any case, we now made this guy abstract. Say abstract class. All right. So we're no longer allowed to create generic inhabitants, which is just fine for us. Okay. I'm going to go ahead and take out, actually, I'll leave that in there for now as part of the starting point for the homework. All right. So what we want to do I'm going to go ahead and take out any confusing stuff as there's part of your starting point. There's an exit. Fine, that's fine, that's fine. All right, so save that. This is another starting point. All right, homework. Build a dungeon with at least 6 rooms with exits between the rooms. You might choose to model the CS department, but do whatever you want. Yeah, this is the CS department. All right. So so you're going to build a bunch of rooms. You're going to build exits. So like, for instance, this room might have an exit. Maybe we call this to the south. So you'll put an exit there. So inside of a room, you're going to have a way of storing those exits. So we're going to say, make sure to add exits to rooms. And so we're going to say, put a single player into the starting room for the dungeon. Put at least 2 monsters somewhere on your map, somewhere in your dungeon. You don't even need to make your guy move around yet if you don't want to. We're basically building the model. If you want to take it, we're good. That's the next step. We're going to start making a move around. But I effectively want us to create a bunch of rooms, a bunch of exits, add those exits to the appropriate room. So we now have that map, right? Throw a player into the starting room of your dungeon and maybe build 2 rats and throw them into some rooms. So we have some monsters and we have some players. You don't have to make anybody move around yet or anything like that. We're going to have our starting point for our dungeon. Actually, the actual map of our dungeon. All right, I'll go ahead and give you this. That is a starting point. And we'll say submit a link to the code and the self-assessment. Questions, comments? Go ahead.
You want us to create the rooms and exits inside the dungeon creator, or?
That would be up to you. I would say that's probably the most appropriate, but for right now, do it in the way that makes the most sense to you, because we're going to be upgrading it. All right. Other questions, comments, concerns, bribes? All right. Everybody have a good weekend.
Did the picture come in? Did the picture come in for the?
Oh, the new paintings?
Yeah.
Not yet. I emailed Park West to see what the holdup is, and they asked for a copy of the invoice. So I wonder if they think it's lost, but I sent it to them, so I'm sure we'll get it.
Good question there.